Section 9.3 is geometric sequences. Our goal is to define, identify, and apply geometric sequences. On page 703, we have, you build a geometric sequence by multiplying each term by a constant. In a geometric sequence, the ratio of any term to its preceding term is a constant value. A geometric sequence with a starting value a and a common ratio r is a sequence of the form a times r squared, a times r cubed, and so on. A recursive definition for the sequence has two parts. The initial condition, a1 is equal to a, and the recursive formula, a sub n is equal to a sub n minus 1 times r for n greater than 1. An explicit definition for this sequence is a single formula, a sub n equals a sub 1 times r to the n minus 1 for n greater than or equal to 1. Example 1 says, is the sequence geometric? If it is, what are a1 and r? For part A, we have 3, 6, 12, 24, 48, and so on. For part B, we have 3, 6, 9, 12, 15, and so on. For part C, we have 3 to the 5th, 3 to the 10th, 3 to the 15th, 3 to the 20th, and so on. To check if there is a common ratio, we take the second term and divide it by the first term. 6 divided by 3 gives us 2. And then we repeat this for the following terms. 12 divided by 6 also gives us 2. 24 divided by 12 gives us 2. 48 divided by 24 gives us 2. Another way to look at this is to say we multiply by 2 every single time. Therefore, the common ratio is 2, and the sequence is geometric. So our initial term is 3, and r is 2. For part B, we have 6 divided by 3 does not equal 9 divided by 6. It also doesn't equal 12 divided by 9, and it also doesn't equal 15 divided by 12. Since the ratios are different, the sequence is not geometric. For part C, we have 3 to the 10th power divided by 3 to the 5th is equal to 3 to the 15th divided by 3 to the 10th is equal to 3 to the 20th divided by 3 to the 15th. Using the properties of exponents, we know if we have the same base in the numerator and denominator, we can simply subtract the exponents. So 10 minus 5 gives us 5, 15 minus 10 gives us 5, 20 minus 15 also gives us 5. So the common ratio is 3 to the 5th, and the sequence is geometric. Our initial term is 3 to the 5th, and r is 3 to the 5th as well. The work for this problem is written out on the next few slides. And now I would like you to try number 1, determine whether each sequence is geometric. If so, find the common ratio. We have 1, 1/2, 1/3, 1/4.